You can now see the results. Observations are 10 and summation of x is, or sum of all the values given in the data, is 409. Sample mean is 40.9. Sample variance is 157.211. And sample standard deviation is 12.54 rounded off to 2 decimal places. So 40.9 is the mean and 12.54 is the standard deviation. 40.9 is the mean and 12.54 is the standard deviation. And the total number of observations we are given in the data are 10. Now we write down the formula x bar minus t alpha by 2, standard deviation of a sample divided by root n, x bar plus t alpha by 2, sample standard deviation divided by root n. So what we need to do, we need to further locate the t alpha by 2 value. Let's suppose you are asked to construct 95% CI for mu. What this mu is indicating, since the data are related to the wages of 10 workers working in the construction industry or at a construction site, therefore we can generalize our opinion on the basis of the mean estimated for the entire population, that what is the minimum and what is the maximum possible wage in the entire industry for which we can be 95% confident. And for this purpose, we need to obtain from T table the T value corresponding to 95% CI for the degrees of freedom of 10. So how do we denote this entire thing? T.025, that is representing the 95% CI related subscript, and the number of degrees of freedom are n minus 1. 10 minus 1 gives us 9. So what we do, we go to the T table, and in the T table we go to the ninth row and go to 95% CI column, which is the middlemost. So at the intersection of 9 degrees of freedom and T.025, we get 2.262 as the T value. So that's the value, 2.262. Now we make substitution in the formula. 40.9 minus 2.262, then we have standard deviation of 12.54 divided by square root of 10, 40.9, 2.262, 12.54 divided by root 10. So first of all, we'll compute the margin of error part of the CI formula, and for this we need to multiply 2.262 by 12.54 and then divide this by square root of 10, and this would give us 8.9699. So we can round it off again to 2 decimal places, 8.97. So what we do, 40.9 minus 8.97 would give us 31.93, and 40.9 plus 8.97 would give us 49.87. Now, how can we interpret this answer? We can interpret this answer as, we can be 95% confident that the mean wage of all the workers working in the construction industry lies between 31.93 and $49.87. Again, interpreting the margin of error in estimation E that we have already computed as 8.97. How can we interpret the margin of error? We can interpret it as the estimated mean wage of all the people working in the construction industry lies within $8.97 of the actual. This is how we interpret the margin of error in estimation. Now, what if we would like to reduce margin of error in estimation? And for this purpose, we need to draw a greater sample size or work with the greater sample size. And the formula for T in that case would be this one. Now, if the margin of error we would like to reduce to 4, so the new margin of error is 4. We assume the sample standard deviation to be same, and we are using the same standard deviation of 12.54 and same t value for 95% CI we would be using. And after making substitution here in the formula, 2.262 times 12.54 divided by plus minus 4. No problem in writing it down with the plus minus 4 sign, because when we raise it to square we get plus minus sign will be eliminated. It is only the positive value we will get it. So 2.262 times 12.54 divided by 4 squared gives us 50.28 as the sample size. And as we all know that sample sizes are to be rounded off to the next, to the, so we in fact round it off to 51. 51 is the sample size desired to have the margin of error of 51, to have the margin of error of plus minus 4. So if the margin of error is to be reduced to 4, we need to have the sample size of 51 for the given value of standard deviation and at a given 95% CI.